Welcome to Science Stories Unlocked, the podcast where scientists stop being dusty or intimidating textbook names and start becoming actual human beings. Today's episode is about one of the greatest genius in history, Archimedes, the man who supposedly ran naked through the street yelling Eureka!
Oh, I've heard about that story. It honestly sounds less like a scientist and more like someone who just found their missing phone charger after 2 weeks.
Yeah, true. But Archimedes wasn't just eccentric. He explained why things float, estimated pi with shocking accuracy, invented machines, and became one of the most famous mathematicians of the ancient world. Joining me today is Kiyoung, a physical science student who recently learned about buoyant force in class.
Yeah, we just started learning why things float and sink. My teacher kept mentioning Archimedes, so I wanted to know more about him.
Perfect, because once you learn the story behind the science, physics suddenly becomes way more interesting. Let me first talk about who Archimedes is. Archimedes lived over 2,000 years ago in the Greek city of Syracuse. Back then, people described him as completely obsessed with solving problems. Legend says he sometimes forgot to eat because he was so focused on math.
Okay, forgetting homework, sure. Happens to me sometimes. But forgetting food? No.
No. Apparently, even while taking baths, he kept thinking about science, which leads us to the most famous bathtub in history. That's the Eureka moment. The story goes like this. One day, the king asked Archimedes to solve a mystery. The king had paid a goldsmith to make a crown out of pure gold, but he suspected the goldsmith had secretly mixed in silver and stolen some of the gold. The problem was, how do you test the crown without melting it?
That actually sounds impossible.
At first, Archimedes thought so too. Then one day, while stepping into a bath, he noticed the water level rose. Suddenly, he realized objects displace water, and the amount of water displaced depends on the object's volume, not on its weight. If the crown contained silver instead of pure gold, it would still have the same volume, but it will have different weight. Ah, Archimedes exclaimed, I know what to do. According to legend, Archimedes got so excited that he ran through the streets yelling, Eureka, Eureka, which means, I found it.
Wow, that must have been quite a sight. I still can't believe one of the biggest science discoveries started in a bathtub.
Science can happen anywhere.
I remember you said it was a legend. Does that mean it might not be true?
Maybe, yes. Historians aren't completely sure the story happened exactly that way. But even if the details were exaggerated over time, the legend still captures something real. Archimedes' curiosity, excitement, and the brilliant insight about how science works. Okay, let me explain how Archimedes solved the problem step by step. First, let's talk about why things float. That is because of a force called buoyant force. The idea is pretty simple. When you put something in water or any kind of liquid, if the upward force from the water is greater than an object's weight, it floats. If the object's weight is greater, it sinks. The upward force is what we call buoyant force. That explains boats, submarines, and even why giant steel ships can float. Let's break it down a little more. Suppose you have a heavy, irregular-shaped object.
Like King's Crown?
Exactly. First, you weigh it in air. You simply call that its real weight. Then you lower it completely into water, but don't let it touch the bottom if possible. At this position, weigh it again. This new reading is called the apparent weight because the object seems lighter in water. The difference between the real weight and the apparent weight equals the upward force from the water supporting the object.
That's called the buoyant force, right?
That's correct. The difference between the weight and the apparent weight is the buoyant force. According to Archimedes' principle, the buoyant force is equal to the weight of the water displaced by the object. That was Archimedes' big insight. So if you know the buoyant force, you can figure out how much water the object displaced, and from that calculate the object's volume even if it has a strange shape. Then you divide the real weight of the object by its volume, you get its density. Then you can compare that density with the density of gold which is known. That way you can see if the object is made of real gold or something else. Eureka! Let me summarize it briefly. It all boils down to an important point. You have to measure the volume of an irregular thing. 2 ways you can do it. Method 1, you put it in water, see how much water it displaces. The volume of the displaced water, of course, is equal to the volume of the irregular thing. Method 2, you can measure the real weight and apparent weight of the irregular thing. The difference between these 2 numbers is the buoyant force. Then you divide this difference by the density of the liquid, that is the volume of the irregular thing.
Does that mean that the density of the liquid also affects the buoyant force?
Yes, it does. So if you go to the salt lake, you get more buoyant force because salt water has higher density than regular water.
So cool. Honestly, hearing the story behind the formula makes it much easier to remember.
That's great. And that's exactly part of the goal of this podcast. Okay, in addition to buoyant force, Archimedes also became famous for calculating pi.
I know pi. We learned that in, I think, elementary school.
Do you remember what is the number of pi?
Yeah, 3.14159.
That's right. Pi is the ratio between a circle's circumference and its diameter. But back then, nobody knew its exact value. So Archimedes used geometry to estimate it by drawing shapes inside and outside circles. As the shapes gained more sides, they became closer and closer to a perfect circle. Eventually, he estimated pi between 3.1408 and 3.1429.
Without calculators?
Without calculators, computers, or modern algebra.
That is honestly incredible.
Yes. Another thing that Archimedes studied was the lever. It is a simple machine that helps lift heavy objects. He famously said, "Give me a place to stand and I will move the earth."
That sounds like something a superhero scientist would say.
And the amazing part is the physics behind it was real. Even today, cranes, crowbars, scissors, and the seesaws all use the lever principles Archimedes studied over 2,000 years ago. Let's talk about the tragic end of Archimedes. Eventually, Rome attacked Syracuse. According to another legend, Archimedes was working on a geometry problem when Rome soldiers entered the city. A soldier approached him, and Archimedes supposedly said, "Do not disturb my circles," which may be the most mathematician sentence ever spoken. The soldier killed him anyway. Later, the Roman general was reportedly angry because he had wanted Archimedes captured alive.
Even Rome respected his genius. That's honestly really sad.
It is, but it also shows how deeply Archimedes cared about discovery and knowledge.
So today we learned that Archimedes explained buoyant force, estimated pi, studied levers, ran naked and yelled Eureka through a town, and became one of the greatest scientists in history. That's a pretty impressive resume.
Yes, it is. And maybe the coolest part is this. Science isn't just memorizing formulas, it's curiosity, asking questions, and noticing things other people miss, even something as simple as water rising in a bathtub. Thanks for listening to Science Stories Unlocked. If you enjoyed today's episode, share it with a friend who may think science is boring, because Archimedes would definitely disagree. See you
guys
next
next time.
time.